All right, welcome back everybody. So we're going to look at all of the different symmetries here. So what we're going to do is we're going to start with the polar axis symmetry, theta equals pi over 2 symmetry, and then finally symmetry about the pole. So these are going to be the three types of symmetry that we have. So this is going to be polar axis, which is like our x-axis, theta equals pi over 2, which is like our y-axis, and then symmetry about the pole, which is our origin symmetry. And there's going to be a couple different ways that we can do this because we don't have uniqueness. So there's actually kind of two checks that we have in each case here. So what I'll note is our original coordinate is going to be r theta. So this is going to be our original coordinate, and then we're going to move it to these different locations in two different ways. And so for the polar axis symmetry and theta equals pi over 2 and the pole, what we're going to want is two representations of our coordinates where we use a positive r value and a negative r value. That's really what each one of these is going to look like. So it's going to be r comma something and negative r comma something. And again, the reason why we need that is because we don't have uniqueness of coordinates, so we need to account for all different ways that we can represent our polar coordinates. And the key idea is if the radius is positive or negative, then the angle measure that we choose will give us the two possible locations of our expression that will be symmetric in this case. So if I look at each case then, our goal is going to be to figure out, okay, what do I need to do to theta to make it fit with the given coordinates plus or minus r? So if we look at our polar axis case, well, if I measure myself out r units, then to get to that first coordinate with positive r is just going to be to rotate clockwise. So rotate in the negative direction. So then I'm just going to use negative theta. So r negative theta is going to be our first check. And then if I started with negative r to get to that point, I could rotate counterclockwise from the location here, which is 180. So I'm going to rotate from pi. And so the angle I'm going to rotate from pi, we'll note if this is going to be theta, then I'm going to rotate the difference between pi and theta. So this is going to be negative r comma pi minus theta. So these are the two checks for our polar axis symmetry. Maybe we'll create some dividing lines here. So we'll note if r negative theta corresponds with r theta, or if negative r pi minus theta corresponds with r theta, then we have that particular symmetry. And we'll discuss kind of how to check that symmetry on the next set of notes. So for theta equals pi over 2, we'll do the same thing. So we'll note that for positive r here, so if I rotate to theta, that's going to be the original location, and then the symmetric point is going to just be pi minus theta with positive r as well. So again, we get that pi minus theta angle measure. And then if I did negative r, so again, measuring in the negative direction, now I'm just going to rotate clockwise, which means I'm going to have negative r, negative theta. So then we'll have r pi minus theta or negative r, negative theta, mapping to r theta. And then if we're about the pole, then if I measure out r, I can go in reverse here. So this would be negative, or I could go in the positive direction. So we're going to go in the positive direction. So we're going to go pi plus theta. Oops. That's going to be pi plus theta. And then if I measured in the negative direction first and then rotated, that's just going to be pi comma theta. So negative r theta. So we're going to get r comma pi plus theta, r theta, or negative r theta to r theta. So again, there's two checks that we're going to need to use in any given case. But note what we're saying here is that these are on the same graph, which means if I substitute in these equation values for r and theta, we should get the same equation as the original. All right, and that's going to be the way that we can check these. All right, so this is going to conclude the first part of our graphing notes here. So we'll go ahead and pause here until we go to the second set of notes for graphing. And so if you do have any questions, shoot me an email or drop by my office hours. Until